Okay, tangent ratio is what we're going over today. This is one of three major ratios. We're going to focus on one today, and then your lesson after your quiz Monday will focus on the other two. Now, tangent ratio, okay, let's get this real pen here. It's set up like this. On your calculator, you're going to read something that says tan, okay? This symbol is called theta, and it stands for an angle, okay? Depending on what angle we're using. So tan theta is equal to the opposite side of the triangle divided by the adjacent side of the triangle. Okay? And you might go, what the heck do those mean? We're going to figure that out. So, if this is our theta, this angle here, and we'll call this triangle ABC. So, we're trying to, or maybe we have angle A, maybe we're trying to find angle A. Everything is in reference to an angle. You're going to understand what that means in a moment. But if this is angle A, what would be considered the opposite side of this triangle?
Between B and C.
Between B and C. We also normally call that what side, if you guys remember. If this is angle A, this would be considered side A, right? Side A would be our opposite. That's what's very important. So I'm not going to write A in there because it might start to confuse you with adjacent. This would be our opposite side of the triangle. Okay? Now, adjacent means to touch. This is a right angle triangle, and I should have mentioned this to start. This ratio only works with right angle triangles, which is exactly what we've done with Pythagorean theorem. Okay? Pythagorean theorem only works with right angle triangles, so does tangent ratio. So, because this is a right angle triangle, according to this angle, there are technically two sides touching it. We have this side and this side. But one of these sides already has a name. Anyone know what it's called? Yes, which side is that? The longest side. The longest side already has a name. It's the hypotenuse. Okay? So, no matter what we do, the hypotenuse never changes. It's never the opposite side of an angle we're looking for, and it's never the adjacent side. It's always called the hypotenuse. So, luckily by deduction, if we ever get confused, as long as we know what the hypotenuse is, and we can figure out what the opposite side is, we know whatever's left would be our adjacent side. But with that being said, adjacent means to touch. This is one of the sides that is touching this angle. That's what that means, adjacent, okay? But it's not the hypotenuse. Our adjacent is never the hypotenuse when setting this up. So, the opposite side would be this guy over here, and the adjacent side would be this side over here. So if we had measurements, we would be using those. Now remember I told you this is completely in reference to what angle we're talking about. I'm going to remake this triangle. Okay, so imagine this is the exact same triangle, triangle ABC. But this time we're talking about angle C. Now we will not talk in our ratios about the right angle. Okay, because we already know what that angle is. We already know it's 90 degrees. There's really no reason to go about finding it. So if we're at angle C, we already know this side will be the hypotenuse. Oops, let's spell that right. Okay. So if this side is already the hypotenuse, we'll just short form this. What is now our opposite side? Anyone know that?
C.
Yeah, side C or the side between A and B. Perfect. This then becomes the opposite side. So this ratio, we'll open it up a little. This ratio is completely dependent on what angle we're referring to. That's very important. Opposite and adjacent can change in a triangle. They're not static. So this now becomes the opposite side, which means what is our adjacent side? Between B and C, right?
Can you go over that again?
So, angle A, opposite side of this angle will be the one side not touching it. So we know that this side is touching the angle and this side is touching the angle, which means this side over here must be the opposite side. So depending on what angle we're talking about, in this case A, this will be the opposite. In our other triangle, we were referring to angle C, which meant this was a side touching it and this was a side touching it. So the opposite side is the only side not touching that angle. Okay? Opposite and adjacent can always change. If you notice, we drew the exact same triangle. The opposite was on the bottom here, but on the second triangle, the opposite was on the part that was standing vertically.
And
Okay?
another question. Can you
Right? So there is no opposite side of B because that's called the hypotenuse. We already have a name for that. That will not change. Okay? So now that we have that information, let's actually go about solving a couple questions. This is setting up tangent ratio. Okay? Actually, maybe we'll leave. So let's actually set up the tangent ratio. For the first question, angle A is our theta. So if I'm looking for tan theta, my opposite side, okay, and remember these would be the sides. This would be side A, B, and C. Okay, my opposite side would be side C, and my adjacent. Oh no, sorry, my opposite side is side A, and my adjacent side is side C. If you guys notice, right? This is my side A. That's opposite. Adjacent is side C. That's our adjacent. So we'd have tan theta is equal to side A divided by side C. In the second triangle, theta is at a different angle. So in this one, we have tan theta is equal to the opposite side. Remember, this is still side C, side B, and side A. The opposite would now be side C, and the adjacent would be side A. So do you see how these vary? We've actually set up the reciprocal depending on whether we're working with angle A, this one was angle A, or angle C. We end up getting the reciprocal in terms of the ratio. Okay, so again, very important on what angle we're working with. All right, so that's setting up tangent ratio. Then we're going to solving with tangent ratio.